Good morning, students. Once again, we are in continuation with the alternating current and AC circuits. So, on the previous turn, before the exam or test, we were doing the AC circuit. What we have done. So, we'll revise what we have done. So, as in the previous lecture, we have defined the alternating current and alternating voltage. What is AC and AC voltage, and some important definitions regarding the AC. So in the important definitions, the current amplitude, that is the peak value of current represented by I0, peak value of voltage represented by V0 or voltage amplitude. Frequency, number of cycles completed in one cycle, is called frequency of AC. It is represented by F, small f. Time period or periodic time, the time taken to complete one cycle of AC, that is called periodic time. So, AC current we have done, and voltage, so this is I equal to I0 sin omega t and V equal to V0 sin omega t. They are periodic functions with sin omega t. Omega is angular frequency, t is time, I0 is the peak value of current, V0 is the peak value of voltage. Here omega equals to 2 pi upon t, and this 1 upon t is expressed as f. So f is, or t is time period, and f is frequency. So it is measured in hertz or second inverse. This is in second. And we define the phase. It is represented by phi. If the current or voltage is having initial phase, so current or voltage is expressed as I0 sin omega t plus minus phi, or V equal to V0 sin omega t plus minus phi, where phi is phase difference. Phi is phase difference. And afterwards we define some important terms, that is average value of AC and average value of voltage or AC voltage. So average value of AC current or alternating current. So it is expressed as I, or this I equals to 2I0 upon pi, or we have given 0.637 I0, or it is 63.7% of I0. It is in half cycle. of AC. Similarly, average value of AC voltage, that is V bar equal to 2 V naught upon pi. It is 0.637 V naught and it is 63.7% of peak value of voltage. It is also in half cycle. In complete cycle, of AC, I average is 0 and V average is 0. These are the average values and average voltage. So meaning is this is time axis, suppose this is current. So this is the half cycle, 0 starting from 0, this is half cycle, time taken to complete, half cycle is T by 2 and this is T. So in the half cycle the value of current starts from 0 and increases to the maximum one, that is I naught. This is current amplitude or this is I naught. And then it decreases to 0. Similarly in the opposite direction, the remaining half cycle. So in the half cycle we can calculate the average value of current and average value of voltage in the similar manner. So this is the positive half cycle. This is the negative half cycle. So the same value of average value of current in negative half cycle is with negative sign. Similarly, it is with negative sign in negative half cycle. But in complete cycle, the average value positive and equal value of negative. So average value of current and voltage is 0. Now the next is RMS value of current. So IRMS, that is square root of mean of square, and its value is I naught upon root. This is the RMS value of current, or it is called 0.707 I naught, or it is 70.7% of I naught. Similarly, VRMS, that is square root of mean of square of AC voltage, and its value is V naught upon root 2, or it is 0.707 V naught. So in this way we can determine, and we have given the proof of in the previous lecture, RMS value, how to derive IRMS. Similarly we can derive the RMS value. Now the next is the we have given the phasor diagram. Phasor diagram and phase difference. So you can go through the previous lecture and afterwards the AC circuits. In the AC circuits, we have covered the first circuit, that is ohmic resistance only. Number 2, inductive circuit only. Inductive or inductive only. Number 3, capacitive only. So we have given these 3. So important points of ohmic circuit or ohmic resistance only. In this we have given the circuit diagram, and the main point is the current and voltage are in the same phase. This is the direction of current and voltage will be in the same. So phase difference is 0 in this case. Now inductive circuit are having coil of inductance L only or purely inductive. In this circuit, the voltage across the coil which leads the current, this is the current, this is voltage VL or V. So this is the phase difference. So phase difference between V and I, so it is plus pi by 2 or pi by 2. And the resistance of this coil is called reactance, and represented by XL, it is omega L or 2 pi f. So it is measured in ohm. So this is for inductive, and for capacitive, so here this is the direction of current and voltage lags behind. This is for capacitance, and it is phi equal to minus pi by 2. So again there is the phase difference of, and this reactance, or reactance means the resistance offered in the flow of current, that is reactance. It is represented by XC, or XC equal to 1 upon omega C or 1 upon 2 pi FC, and measured in ohms. So these are the important points of what we have done in the previous lecture. Thank you.